In this video we're going to quick review the fundamental theorem part 1 and also start finding the area between curves, which is actually very easy. If you found the area under a curve, you can certainly get the area between curves pretty easily. Here we're asking for the derivative of the integral. So this one just goes from 2 to x. So if you recall from yesterday, that just means our answer will be the original function, but instead of a t, it will have an x. And the reason is, if you went to the work of finding the antiderivative, plugging in x and 2, then found the derivative, your derivative would now be in terms of x. The next problem, you can see that our bounds are from x to 3. That's not the way we usually like it. We usually like to go from the constant to x. But if we change our bounds, we simply change the sign of the final answer. So the answer would be negative sine of x. And finally, now we're going from a constant to a function, the kind of complicated function. You know, over here it was just x. So that means that our answer, we'll still substitute that in. We'll have 2 multiplied by 3x to the 4th right here. But we're going to take our entire function and multiply it by the derivative of the bound, like that. Okay, and recall, we really did that over here as well. It's just that the derivative of x was 1. And of course we don't, we could have said, well, multiplied by 1, multiplied by 1. It's just that normally we don't do that. Alright, I'm going to find the area enclosed by the lines, the vertical lines, x equals 0, x equals 2, and the functions x cubed and 2x plus 5. So I'm going to just kind of see if I can't outline this. I'm finding the area of this shape. Okay. Now, the way to do that is to find the area below the line. Okay. Which, of course, we would get by, let me stay with the color, the integral from 0 to 2 of 2x plus 5 dx. Okay. And notice the 0 and 2, the vertical lines, all they did was give us the bounds. And then I could find the area below the cubic, okay, which I would get with the integral from 0 to 2 of x cubed dx, and then I could just find the difference. Okay. Now, one thing that we had talked about a week or so ago, we first started talking about the properties of integrals, was the fact that if I'm subtracting two integrals that have the same bounds, I could combine them to be just one integral and just have 2x plus 5 minus x cubed, which might aid me in having to do a little less work at the end. Okay, the antiderivative would be x squared plus 5x minus 1/4 x to the 4th, evaluated at 2 and 0. If I plug in 2, I'll get 4 plus 10 minus 4. So I'll get 10. If I plug in 0, I'll get 0. So the final answer is 10. There are 10 units of area enclosed by those 4 things, the 2 vertical lines, the line 2x plus 5, and the cubic. So it really is just as easy as doing an integral with the top function minus the bottom function. Let's do one more. The function x squared and the function 4x. Okay, so you can see that. So we're finding this area in here. Okay. Now, I gave you a graph, so I hope you can easily see what the bounds are. They're going to be 0 and 4, it's simply where they intersect. If you didn't know that, let's say you didn't have a graph, you could easily get the intersection points by setting them equal to each other. I, with something like this, would subtract 4x. I always look to factor, and then you'd say, okay, so 0 and 4 are the solutions. Those are the intersection points. That makes up the bounds of our integral. Now the next thing you got to be concerned about if you don't have a graph is which function's on top and which function's on the bottom. Maybe the easiest thing to do is to pick an interior point. By interior I mean one between your bounds. So maybe 2. If you plug 2 into f of x, 2 squared is 4. If you plug 2 into g of x, 4 multiplied by 2 is 8. So g of x is the top function. So we do top minus bottom, like that. Okay. The antiderivative would be 2x squared minus 1/3 x cubed, evaluated at 4 and 0. Now if I plug in 4, I get 32 minus 64 thirds. If I plug in 0, I get 0. So 32 minus 64 thirds, I could maybe rewrite 32 as 96 thirds. So I have a common denominator. So the final answer would be 32 thirds. Now, if you didn't have a graph and you were running short of time, or you just weren't sure which function was on top or bottom, one thing you could do is just go for it and try it. And if you did x squared minus 4x, the only thing that would be wrong in the end is your answer would be negative. Now remember, one of these words we've been looking at is bounded. Okay, bounded area should always be positive. So if you got negative 32 thirds, you could simply change it to be positive 32 thirds, regardless of where the functions that you're looking at are. Even if they were all down here, it was all negative, functions, the area bounded between them should always be positive.